In continuation, to our previous class, RC circuits, we are working on some simple models. Thumb rules that you need to still remember is, in an RC circuit, at t is equal to 0, an uncharged capacitor behaves as a conductor, as simple as a connecting wire. A long time after closing the switch, it behaves as an infinite resistor, open switch. This is the thumb rule. On the basis of this only, we have done some problems in our previous class. Today we will do some more. In the diagram shown in the figure, find the potential difference between points A and B, between the points B and C in steady state. So what is my steady state circuit? Honestly speaking, nothing. No current flows. Because wherever you go, you have a capacity. So at a steady state, what happens? At a steady state, no current flows through 20 ohm and 10 ohm resistor. In that case, this is A, this is C. Since there is no current, this is A, this is C. If I assume C is grounded, 0 volt, and it will become 100 volt. This is the first stage of the problem. Any students having doubt on this, ask me right now. I'm asking you again. If any student is having doubt on this, ask me right now. Can you ask your question again, please? When there is no current through 20 ohm, how come current through 10 ohm? Because there is a closed loop. This is a closed loop. When there is no current through this, suppose if the battery is giving I current, for example, definitely the same I current will come over here through the 10 ohm. When there is no current through this, there won't be any current through this. Battery won't deliver any current because these ends, there is no resistance. There is no conducting path in steady state. So finally, this circuit is same as, this circuit according to me is same as 1 microfarad, and those 3 ohm and 3 ohm are in parallel. That will become 6 ohm, 6 microfarad, 1 microfarad are in parallel. That will become 2 microfarad. Previously I uttered, I think 3 ohm, not 3 ohm. It is 3 microfarad, 3 microfarad, 3 microfarad. Boys, here is your B. Here is your A. And here is your C, which is 0 volt. This is 100 volt. Obviously, above the circuit is in series, 6 microfarad, 2 microfarad series. 3 is to 1. 3 is to 1. So 3 is to 1 capacity means 1 is to 3 potential drop. So which obviously means this should be 75 volt. So what is the potential drop across AB now? 25 volt. What is the potential drop across BC? 75 volt. Ram Kartikeya, you may question me. ఈ క్వశ్చన్స్ కూడా డిస్కస్ చెయ్యాలా మాకు వచ్చు కదా. When today is Tuesday, when I am going to discuss a very higher order problem, this is like a warm up for us, technical. Right. Next. Unless or until mentioned, generally we will take as steady state. In the given circuit, E1 is 3E2. E3 is 3 volt. E1 is 6 volt. E2 is 2 volt. Right. R1 is 6 ohm. R4 is 3 ohm. R2 is 2 ohm. R3 is 4 ohm. And C is 5 microfarad. Find the current in R3 and the energy stored in the capacitor. Nothing is mentioned. So we will assume that this is to be in steady state. Boys and girls, see the path. This is the path that will be isolated under steady state. So what is my steady state circuit? Before I start using the term steady state, I will label it as A, B, C, D. E2, R2, A. Remember, this is B or C, both. E1, T, in fact, this is a 3 ohm. And R3 is a 4 ohm. R2 is a 2 ohm. Right. Fortunately, I know the potential drop across VC and VC minus VD. And by the way, this is E3. Out of all, which is higher? E1 is higher. So majorly, I am assuming this is how the current, main current I flows. And this is some I1. Okay. And again, this is I. So what is going to be the current in this? I1 minus I. Now, please confirm me any doubt in these observations. Any doubt in these observations? I am believing that I1 is the huge source. I1 minus I, obviously. If I am wrong, for example, That will be taken care in the sense of sign itself. Any doubts? Mahalakshmi, do you have any doubt? నువ్వు చేయలేదు ఈ క్వశ్చన్, మళ్ళా చెరిపేసి చేయమంట. కానీ ఏమవుతుందంటే మన ఎందుకు రైట్ E2 plus 2 times I minus I1 minus I into 4 plus 3I plus E3 is equal to 0. Right. Okay, na? Clear? Right. Two I plus 4I, 6I minus 4I1 plus 3I. E3 is 3 volts. I1 minus I ని రాశాక E1 రాయొచ్చు అంటారు ఈ ప్లేస్ లో. రైట్, దట్ ఆల్సో వీ కెన్ గో విత్. అరే అన్ని చేయొచ్చురా, అన్ని ఎగ్జామ్ లో చేయటం లేదురా. మీరు ఎగ్జామ్ లోకి వచ్చేటప్పుడు చేయటం లేదు. నాకు బాగానే సజెషన్స్ ఇస్తారు. క్లాసులో దిక్కుమాలేదో చాలా మంది ఉన్నారు. ఏం వేసామో అర్థం కాదు వాళ్ళకి. ఎవరు చెప్తారు వాళ్ళకి? నీ సంగతి నువ్వు చూస్తున్నావు, మిగతా వాళ్ళ పరిస్థితి ఏంటి? 10 మంది ఉన్నారు కనెక్ట్. ఏం చేస్తున్నావో తెలియని ఇప్పటికే. అనిహాల్ గారు నిన్న నిద్రపోతున్నాడు క్లాస్ లో. వాడు ఆ శివ సార్ కు రిలేటివ్ అనుకుంటా, ఆయన మార్చట్లేదు సెక్షన్. అంతే కదా, లేకపోతే ఈ పాటి గంట వదలబడే. అడుగు, నువ్వు కాల్ చూసి అడుగు ఎన్ని మార్కులు వచ్చా అన్న ఎగ్జామ్ లో. అయినా కూడా వాళ్ళ ఇంట్లో గొప్ప మంచి సెక్షన్ లో, ఫస్ట్ సెక్షన్ లో. అందుకు నేను భయపడి వేయటం లేదు. రైట్, ఈవన్ రాసుకోవచ్చు. ఈవన్ అంటే 6 volts. ఇప్పుడు దిస్ ఇస్ -6I ఈజ్ ఈక్వల్ టు 1, అంతేనా? I ఈజ్ ఈక్వల్ టు 2 3 5 రా. 5 minus 6 minus 1, 6I1 ఈజ్ ఈక్వల్ టు 1. రైట్ రైట్, ఇప్పుడు నాకు సబ్స్టిట్యూషన్ చెప్పండి కరెక్ట్ గా. 2 plus 2I minus 6 plus 3I plus 3 is equal to 0. 2I plus 3I, 5I minus 4 plus 3 minus 1 equal to 0 కదా. I is equal to 1/5. I think I am done. Why? What is VA minus VC now? VA minus VC is E2 plus 2I. What is E2? 2. 2 times 1/5. 12/5. 2.4 volt. That is the same thing across the capacitor. So what is the charge in the capacitor? 2.4 into 5 10 power minus 6. 2.4 into 5. 12 microcoulomb. And what is the current in R3 area? You know what is the current in R3? It is simply current in R3 is E1 by R3. E1 is 6, R3 is 4, 1.5 amps. Okay, what is the energy stored in the capacitor? The energy stored in the capacitor is half CV square, half into 5 into 10 power minus 6 into V square, 2.4 into 2.4. 1.2 or whatever it is, that is your answer. Any doubts? Clear? Right. I am still doing basic models only. Initially and finally. Current, calculate the current flowing through the capacitor branch in the circuit shown in the figure, initially and finally. See, at t is equal to 0, capacitor behaves like a conductor. Capacitor behaves like conductor. So this is a 10 volt, 4 ohm, 1 ohm, sorry, 2 ohm, 2 ohm. That's the circuit. Totally 5 ohms. So current drawn is 2 amps. So 1 ampere goes here and another 1 ampere goes here. Yet t tends to infinite. Capacitor behaves like open circuit. Current is high. 10 volt. Capacitor branch. అంటే బ్యాటరీ నుంచి ఎంత కరెంట్ వస్తుందో కూడా తెలుసుకుంటే తప్పే ఉంది. The current is 5/3 amps and through the capacitor branch it is 0, but across a capacitor there is a charge. The potential drop across capacitor is nothing but I into 2, 10/3 volt. Any doubt? Even if you want, I can give charge also. Any doubt? Asking you again, do you have any doubt in this question? Sure, right? Akka? మీ క్వశ్చన్ నువ్వు మళ్ళీ చేయగలుగుతావు, నేను చెరిపేస్తా ఇప్పుడు. సహస్రాక్షి మొత్తం చెరిపేస్తా ఇప్పుడు. చూరా, రైట్. Everyone start working on this question now. Capacitor shown in the figure has been charged to a potential difference of V volt, so that it carries a charge CV with both the switches S1 and S2 remain open. S1 is closed at T is equal to 0. Okay. At T is equal to R1C, switch S is open and S2 is closed. When the charge on the capacitor at so and so time. First, what is happening? What is happening here? What is happening here? See, from T is equal to 0 to T is equal to R1C. T is equal to 0 to T is equal to R1C. Discharge happens like this. What the time that they have given is one time constant, right? So now what happens to the charge on the capacitor? Charge on capacitor at T is equal to R1C is CV by E, correct. It is a discharge. Q is Q naught e to the power of minus T by tau. So therefore, that charge is CV by E. Now what do you have is so you require some theory related to this. I will teach this after R1, R2, undoubtedly the drop across this is less than V. So, no. First thing that you should judge is, will the capacitor now further discharges or will the capacitor now be charged? How? So since battery is positive plate is connected and the drop across the capacitor, 1 minute, don't stop, don't respond. Small SP, what is at this instant, what is the drop across the capacitor? Sahasrakshari. At this instant, what is the drop across the capacitor? V by E, which is less than V. So therefore, obviously, it gets charged further. So now current flows like this. I am assuming that Q is the charge transferred. Q naught by C is V by E actually, right? Ah, actually, I just have a doubt. Is V? Huh? Ah, no, no. How to take? Whether I go for E or V? Okay, that is okay. That's not an issue at all. What is that you are suggesting me is don't take Q naught plus Q by C. Simply you take instantaneous charge as Q by C. That's okay. But E and V, are they same terms or different terms? That we need to know. Therefore, dq is E minus Q by C is minus dt by minus plus dt by R1 plus R2. Now, this is again a different time again. Now, you are counting, remember? Now, again, reset clock to t is equal to 0. T is equal to 0. అరే నువ్వు వింటలేదు నువ్వు వినవు వింటల్లా బుర్రకెక్కదు స్కూల్లో ఎలా అలవాటు అయిపోయిందంటే ప్రత్యేకంగా నీకే పాఠం చెప్పేవాళ్ళు నాకు తెలియదు ఆ విషయం కొన్ని వీళ్ళందరినీ బయటికి పంపించి నిన్ను ఒక్కనే కూర్చోబెట్టి చెప్పనా తర్వాత వాళ్ళకి చెప్తున్నారు వింటల్లా ఎలా వస్తాయి మార్కులు ఎటా వస్తాయి ఇలాలుగా బుర్ర గోక్కుంటూ గోళ్ళు గోక్కుంటూ ఆడు చూస్తే ఇడి చూస్తే ఎంత తినేది ఏమొస్తుంది నీకు ఇంటర్మీడియట్ చదువుకోవాలి అప్పుడు నువ్వు ఇంకొకసారి నాకు అట్ట కనిపిస్తే గింట వదలడేస్తాను గట్టి క్వశ్చన్ చేత చచ్చూరుకుంటారు వాళ్ళ గురించి ఇవి చెప్తున్నారు ఆ టైంలో ఛార్జ్ ఎంత టీజ్ ఈక్వల్ టు 0 దగ్గర ఛార్జ్ ఇది సివి బై ఈ కదా అది సమ్ క్యూ అనుకుందాం అంతేగా మనం ఆప్షన్ లేదు ఇప్పుడైతే 1/-1/c ఐఎమ్ అస్యూమింగ్ దట్ దిస్ ఈస్ డిఫరెంట్ థింగ్స్ కొన్ని నిమిషాలు వేసేద్దాం So E minus Q by C is E minus V by E times is a constant. No, they are defining some different time for. And they are find no, you should expand this actually. R1C plus R1 plus R2C. Don't consider this now because we have reset the clock. So therefore, you should consider only this part. So yet T is equal to R1 plus R2 times C. Q is equal to C times E minus V by E times. I'm still assuming E and V are different terms. So therefore, CE minus CE by E plus CV by E. CV by E square. This is the final charge on the capacitor. This is the final charge on capacitor at the instant that you have prescribed. Any doubt? Clear? Sure. There are two stages in all. First is the discharge stage. Next is the charging state. Right. Any doubt in this question, please ask me, right? Hmm. You said you have to take R1 plus R2 already. అప్పుడు అది విషయం తప్పంటే ఏమవుతుంటారా ఇప్పుడు మీకు ఎలా అలవాటు అవుతుందంటే మీకు ఒక మూడు ఉంటుంది. నేను ఆగి రషీద్గా పాఠం చెప్పనా, ఒక పర్ల ఏదో గోక్కుంటున్నావు కదా, ఆగి గోళ్ళల్లో మట్టి ఇప్పుడేగా తీసుకోవాల్సి, చాలా ఇంపార్టెంట్. తీసేసుకుంటారంటే నేను ఆగుతాను కదా. నెక్స్ట్ క్వశ్చన్ వద్దా? పర్లేదు, సేమ్ లేదు. ఇలా వీడినోసారి వాడినోసారి ఇంకోళ్ళని ఒకసారి అడిగి చెప్పుకుంటూ వెళ్తే నేను చాలా మంచి టీచర్. ఆప్షన్ 1 అసలు ఇది ఏం పట్టించుకోకుండా చెప్తే ఇంకా సూపర్ టీచర్. ఆప్షన్ 3 అన్ని పట్టించుకుని చెప్తే చాలా కష్టం. యూట్యూబ్ లో క్లాస్ చెప్తున్నాడు, ఆ పక్క క్లాస్ వెళ్ళిపోయేంత వరకు, సీనియర్స్ వెళ్ళిపోయేంత వరకు ఉన్న టీచర్స్ తో చదువుకోవాలి. సడన్ గా 1.5 టైమ్స్ క్లాసెస్ రన్ అవుతుంది. ఒక 1.5 month కి మనం 0.5 ఎక్సెస్ టీచర్స్ తెచ్చుకోలేము. 1.5 month కూడా కాదు, 1 month. అందుకని మీకు ఇప్పుడు షేరింగ్ ఒకసారి అటు ఒకసారి ఇటు మీకు జరుగుతుంది. ఇలా ఫిజిక్స్ లో జరగకూడదని నేను వంశీ సార్ని పెట్టేశాను. అది నిద్రపోతున్నట్టు ఏమొస్తుంది చదువు చెప్పోసారి, ఏమొస్తుంది చదువు. అవన్నీ ఏం పోయింది, నీకు తీపి గుర్తులుగా ఉంటాయి. నాకు భయపడేది ఏమీ లేదు. రైట్. In the given circuit, switch S is closed at time t is equal to 0. The charge Q on the capacitor. All these are very basic problems of RC circuit. Really very basic problems of RC circuit. Recording was stop this. Now try to work on this question, everyone. చేస్తున్నారు నేను నాకు జరుగుతుంది. నెట్ వాళ్ళందరూ ఇక్కడ తీసుకొచ్చి పెట్టుంటారు. వాళ్ళు అది ఆన్ చేయంగానే ఈ నెట్ నాకు మాత్రం ఉండాలంటే తగ్గకపోతే everyone try this question. Oh, in this question, care must be taken. I told you clearly, fortunately, initially there is no charge. We have done this question, this model yesterday. When you see this circuit, resolve this into three portions. One portion is t is equal to 0. This part gives t is equal to 0 part gives you the maximum current condition. T tends to infinite part gives you what is the maximum charge in this? The drop across R2. The drop across R2. What is the drop across R2? Simply R2 by R1 plus R2V potential drop into C. Agreed? Anyone having doubt on this? Anyone having doubt on this? Sure. Doubt in the any? Right. Right. Next. Now, tau effective. Replace the battery with its internal, fortunately ideal. So therefore, R1, R2 by R1 plus R2 times C. Any doubt in this part? Boys and girls, do you have any doubt till this point? Then everything you know. Even Imax also you know. Imax is nothing but V by R. Everything you know now. How? I'll explain. Q is equal to Q maximum 1 minus e to the power of t by tau. The alpha term is nothing but 1 by tau. It is nothing but R1 plus R2 by R1 R2 C. Q naught is, this is Q naught. Any doubts? Okay, very fortunate that there is no resistance in the path. Any doubt in the entire process of solving this question? I'm asking again. Do you have any doubt in solving this particular question, entire process of this question? Boys and girls. Sure. Right. Let's move on to this one. Okay, with this, I will close the basic models. Today, we will enhance our limits of theory to the next level. Right. Only switch S1 closed in figure. Right. What is the steady state reading of the voltmeter? We will respond option wise in this. With S1 closed. Tell me the path. That's the path. Yes. Still open. Still open. With the S1 closed. This was supposed to be the path. But in steady state, no current flows through 6 ohm. So therefore, what is the steady state reading of the voltmeter? 0. Why it is 0? I said very clearly. The circuit. Kamal. Right. So obviously, in this, there is no current in steady state. So, what is the charge on 3 microfarad capacitor? Obviously, the drop is V. So, therefore, Q is equal to CV. 3 into 10 power minus 6 into V. V, they haven't given anything, it seems. How much power does the 12-volt battery supply? Okay, V12 maybe. Maybe V12, that's what I should understand here, which is nothing but how much power does the 12-volt battery supply in the steady state after all the switches are closed? Just after all the switches are closed. That's the question. Steady state, if it is a steady state, what is the circuit? 12 volt, 10 ohm, 20 volt, 20 ohm. Net EMF is 8. Total resistance is 30. So in this case, that's the deal. What is that you want is power. Power supplied is negative actually. Minus VI minus 12 into 4 by 15. What? Mancha number? Which number? Minus 16 by 5, 3 point, minus 3.2 watt. In fact, battery is not delivering anything. Battery is absorbing. Right. What is the charge on 2 microfarad capacitor? By now. So what is the your 2 microfarad? So what is the drop? Assume this is A, assume this is B. VA minus VB is 4 by 15 into 10 plus 12. 2 times, 3 times. 8 by 3 plus 12. మీకే నెంబర్ రావట్లేదు 44 by 3 volt. Right. Thank you. So we are working on charging and pre-charged capacitor. I already shown you the circuit, and I am assuming the key is closed at t is equal to 0. I is equal to plus dq by dt because it is further charging. That's the case what I am taking. Remember, in this case, this is what I am assuming. So this is coming under further charge. What if V is less than V naught? That I will discuss later again. That I will discuss later. Later in the next immediate slide. Now with this you have a condition dq by V minus q by C is dt by R. Apply proper limit. At t is equal to 0, charge is CV naught. At some time t, what is the charge? That is what you want. In this log E, V minus q by C by V minus V naught is equal to minus T by RC. So therefore, V minus q by C is V minus V naught times e to the power of minus T by RC. So finally, q by C is V minus V naught e to the power of minus T by RC. So how to write this properly? That's all. This is Q is equal to CV minus C times V minus V naught RC. Now what is the graphical behavior here? That's interesting. Put t is equal to 0. You will have it CV. Now the at t tends to infinite. See, this is how you will graph it. Any doubt? Even the same thing you can get it from you just differentiate this 0 plus 0 plus 1 by R times V minus V naught times e to the power of minus T by R. Here I naught is V minus V naught. No change in I naught. So what is the potential drop across the capacitor? The potential drop across the capacitor is nothing but Q by C, which is nothing but right. I naught ante it is nothing but V minus V naught by R. Just after closing the switch, that is maximum. Now please go through, and if you have any doubt, please ask me. This is coming under a case where charging and pre-charged capacity. But which case where growth, further growth. Please go through this. You have any doubt, please ask. When I am writing Q, that is what I am writing is that the charge, total charge on the plate. It's not excess charge, extra charge. Okay, na? Next. Hmm. Right. Next. Okay. Now, what if what happens? That's it. Antana? First, the charge on the capacitor plate becomes zero, and then it gets charged. You know why? Because you said V greater than V naught. V less than V naught. So, in that situation, the graph will be completely different. The graph will be something like this. The graph will behave like this. Finally, plus V. అవును ఇదిగో అయింది నేను చెప్తున్నది ఈ కండిషన్. ఈ కండిషన్ అది కూడా అక్కల మీకు ఈ కండిషన్ చూసుకోండి. ఏదైతే మీకు ఇందాక కండిషన్ లో ఏమవుతుందంటే వన్స్ తగ్గుతుంది. Then what happens is once అంటే గ్రాఫ్ యాక్చువల్లీ ఇన్ దట్ కేస్ ఇలా వస్తుంది. సంథింగ్ లైక్ దిస్. ఓకేనా? సో దిస్ ఈస్ రివర్స్ కేస్. నెక్స్ట్ ఇంకా ఎస్ ఎస్ ఆ కేసే చెప్పారు. Yeah. The discharge. Once when the charge across the plates becomes such that the drop is V, battery is also V. Net uh, flow in that loop is zero. So it won't discharge further. There are three different cases. Any doubts? Right. One more case. I've shown you three different cases actually. The circuit shown initially switch was open. Initially switch was open. వెనక్కి తీసుకెళ్లాలని గుర్తు. Initially switch was open. Since long time. Now till this point I did not introduce the constant current source. Till now whatever that I am doing is I am just maintaining constant voltage source on, right? And then it is closed yet t is equal to 0. First, find time constant. ఎప్పుడైనా టైం కాన్స్టెంట్ కట్టేటప్పుడు కాన్స్టెంట్ వోల్టేజ్ సోర్స్ కి ఏం చెప్పాను, కాన్స్టెంట్ కరెంట్ సోర్స్ కి ఏం చెప్పాను రూల్. నియాల్, కాన్స్టెంట్ వోల్టేజ్ సోర్స్ ఉన్నప్పుడు ఏం చేయాలని చెప్పా, కాన్స్టెంట్ కరెంట్ సోర్స్ ఉన్నప్పుడు ఏం చేయాలి, ఎఫెక్టివ్ రెసిస్టెన్స్ పెట్టాలి. నా నియాల ముందర వాడు కాన్స్టెంట్ వోల్టేజ్ సోర్స్ కి అయితే మింగేసావు సహస్రాక్షి. షార్ట్ సర్క్యూట్ చేసి ఇంటర్నల్ రెసిస్టెన్స్ ఉంటే ఇంటర్నల్ రెసిస్టెన్స్ తో రిప్లేస్. ఇది ఎందుకు అడుగుతున్నానంటే ఇప్పుడు ఫస్ట్ అడిగేది ఫైన్ ద టైం కాన్స్టెంట్, సెకండ్ అడిగేది ఐ వాంట్ పొటెన్షియల్ డ్రాప్ వి యాజ్ ఏ ఫంక్షన్ ఆఫ్ టీ across C. Third, current as a function of time across 5 ohm resistor. So your question starts. Completely a different set of question is what I have framed. Now the first part of the question, try to understand the time constant. Now please try to understand at t is equal to 0. What is the drop across at t is equal to, what is the drop across the capacitor? Just after closing that, what is the drop across the capacitor? Across the capacitor, what is the potential drop? How? In steady state lo unte etla 20 volts. You believe that there is no current passing through 5 ohms and hence right. So therefore at t is equal to 0, left portion of a loop is in steady state. So therefore drop across the capacitor is 20. Okay, just before closing the key, right? Any confusion? Any student in the class with the confusion? Initially switch was open since a long time. You open the switch long time. What happens to the left hand side part of the circuit? It's already in steady state. The capacitor is already charged. Right. I want E effective also. How to find E effective? E1 by R1. And there is no EMF source along 10 ohm path. Okay. When you have a constant current source, 3, E1 by R1 plus E2 by R2 plus E3 by R3. If there is a current source, you will write I by 1 by R1, 1 by 5, 1 by 10. Replace the current with infinite. So this will become 70 by 3 volt. That's E effective. So what is R effective? Already written there. 1 by R effective is 1 by 5 plus 1 by 10. So R effective is 10 by 3 ohm. So what is a tau? C times R effective. 0.2 by 3 microsecond. Correct, na? 2 by 3 microsecond. Or is it 0.2 farad? Sorry. Not microfarad, it's farad. Numbers comfort shader. You don't require micro here. It is simply second. So first part of the question I have done. V as a function of t across C. At t tends to infinite after closing the C switch. E effective is 70 by 3 volt. You know this. It is across the capacitor. Right? Yet t is equal to 0. V across the capacitor is 20 volt. Right? Or my point is V as a function of time across C కావాలి. ఎట్లా వస్తుంది? 70 by 3, 20 volts. ఆల్రెడీ చార్జ్డ్ కెపాసిటర్ ఇక్కడే మనం రూల్ రాసాం. సేమ్ కండిషన్ రాసుకోవచ్చు. చెప్పాలి. వాట్ ఈస్ ద రూల్? You are closing this. చెప్పాలి. మీ ఇష్టం లేదు, డెరైవ్ చేయండి. ఇప్పుడు ఎవరుతున్నాడు? వి యాజ్ ఎ ఫంక్షన్ ఆఫ్ టీ అక్రాస్ కావాలి. చెప్పండి. ఏమొస్తుంది? ఫైనల్ గా 70 by 3 రావాలి. అంతేగా? ప్లస్ వి మైనస్ వి నాట్. నాకు ఇప్పుడు చెప్పండి. వి అక్రాస్ ద కెపాసిటర్ ఎట్ టీ టెన్స్ టు 0 ఏమవుతుంది? 20. సరిపోయిందిగా. హలో, put t is equal to 0, 20. T tends to infinite, 70 by 3. సరిపోయిందిగా. Any doubt in this function? Please ask me right now. ఈజీగా చెప్పొచ్చు కరెంట్. ఇప్పుడు ఎట్లా ఈజీగా చెప్పొచ్చు కరెంట్? మీరు యు ఆల్రెడీ నో VC. అంతే కదా? యు ఆల్రెడీ నో VC. సో దాని నుంచి కరెంట్ ఈజీగా చెప్పేయచ్చు. ఆ లూప్కి వేసుకోండి చాలు. ఎలా లూప్కి వేస్తారు? -20 plus I into 5 plus VC is equal to 0. I is equal to VC minus 4. కరెక్టేనా? VC by 5 minus 4. I is equal to 4 minus VC by 5. 4 minus VC by 5. అరే ఇప్పుడు 70 by 15 plus 10 by 15 e to the power of minus t by tau. 60 minus 70 minus 10 by 15 plus 10 by 15 e to the power of minus t by tau. So make function 10 by 15 అంటే 2 by 3. కరెంట్ వచ్చేసి 2 by 3 కామన్ తీస్తే -1 ప్లస్ e to the power of minus t by tau. మనకి కరెంట్ డైరెక్షన్ మైనస్ వచ్చింది. దాని అర్థం మనం తీసుకున్న డైరెక్షన్ కాదు, కరెంట్ యాక్చువల్ గా ఆపోజిట్ డైరెక్షన్ లో. వై? రైట్ సైడ్ కరెంట్ సోర్స్, ఎక్స్ట్రీమ్ రైట్ అండ్ కాన్స్టెంట్ కరెంట్ సోర్స్. దట్ ఈస్ రెస్పాన్స్. నౌ ఆస్క్ మీ, యూ హ్యావ్ ఎనీ డౌట్ ఆన్ దిస్ మోడల్? కరెంట్ త్రూ 5 ohm రెసిస్టెన్స్ వాళ్ళు అడిగింది అదే. ఎనీ డౌట్? కరెంట్ టు 10 ohm రెసిస్టెన్స్ అడిగితే ఈ లూప్ వేసుకో, ఏదో అయిపోతుంది అనుకో. ఓన్లీ కెపాసిటర్ అండ్ రెసిస్టర్ ఆఫ్ 10 ohms లూప్ తీసుకో. అదే అదే లూప్ వేసుకోరా అంటున్నాను నేను. VC by 10 I. ఓకే, ఎనీ డౌట్? యాక్చువల్గా రైట్, ఓకే, నో ఇష్యూస్. ఎనీ డౌట్స్? T is equal to ఇన్ఫైనైట్ పెట్టావు, ఏమవుతుంది? అవును అవును, కరెక్టే. చేస్తావు. ఏ 5 10 ఎవరు చెప్పారు అట్లా? అది ఏ కేసు? కాన్స్టెంట్ కరెంట్ సోర్స్ లేని కేసు. ఇది కాన్స్టెంట్ కరెంట్ సోర్స్. I told you very clearly that I have intentionally given this question, because till now whatever the models that you have done are on the basis of constant voltage source only. Now I have given in a single question both constant voltage source and constant current source. That is how it is different. Any doubts? Right. Next part of the question, I think I might cover only one question. ఏం చేయమంటారు చెప్పండి డిస్కషన్? ఓకే, అడుగు. I'll just stop this.